Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of a Bernoulli distribution, and it is very simple. It is just an experiment that has only two possible outcomes, and that sort of outcomes can be denoted as either success or failure. So success has probability of P, and failure is the opposite, which is 1 minus P. Now, if X represents the number of success in this setting, therefore X has a Bernoulli distribution. Now, a success here may be the event of getting hit, the event of winning a race, or the event of failing an exam. So it doesn't mean just looking at the positive outcomes, but success here is actually related to whatever we are intended to find out, like whatever probability of the interested event, really. Okay, now this distribution has one parameter. I will explain later on about this parameter, but really to put it simply, parameter is just some constant value. So it is a value that determines the shape of the distribution. So it tells you the shape of the distribution. So if the value changes, then the shape of the distribution will also change. Okay, this is the probability mass function of X, where X here is a Bernoulli random variable, and X here represents the number of success. And the formula to find probability of x0 or x1 is given by this formula right here. Then next, you can see that the mean and variance of a Bernoulli random variable is given by this value. So here we are talking about finding the expected value of x is going to be equal to p, and right here is the variance of x is going to be equal to p1 minus p. Okay, now let us just try to visualize what is this really in terms of a simple tree diagram. Okay, so that's what I'm going to do. I'm going to relate what you have learned in the previous chapter with what we're currently doing right now. So this experiment where you have only two possible outcomes can actually be simply represented in this tree diagram, where you have at this point you conduct an experiment, and out of this experiment there are two possible outcomes only. So here is success and here is failure, and the probability of success is given by P, and the probability of failure is given by 1 minus P. Okay, now from this simple process right here, you can actually come up with the sample space. So sample space contains all the outcomes that you can see in a certain experiment or setting, and in this case the sample space is equal to S, and this one is F. Okay, so that's the sample space, and we have learned that the outcomes from the sample space can be turned out into values for a certain random variable. So a random variable is something that has to be properly defined. So in this example, X here is a random variable that defines the number of success. So based on this, you can turn the result here into a certain value that represents the number of success. So in this case, the number of success is 1. So success occurs here, so the number of success is 1, and in this case the result from the sample space here is going to be turned into a value. The value here is going to be 0 because the number of success here is actually 0. Here we observe failure. Okay, so those are random variables X, number of success, which represents the number of success. Yeah. Now we can then come up with a probability to find what is probability of x equals 1, what is probability of x equals 0, and usually we can do it easily through constructing a table. So we can construct a table where we have values of x equals to 0 and 1, and we can clearly find out what's the probability of getting 0. So the probability of getting 0 is just 1 minus p. So here we can write down 1 minus p, and the probability of getting 1 is going to be equal to p. So that's how you can represent the probability mass function using a table. Okay, now another way of representing a probability mass function, as you have seen in the previous chapter where I've talked about how can probability distribution be represented. So this is just something to jog your memory on what you have seen before. So there are three ways of doing this. First, you can construct a table, or second, you can come up with a graph, and third, you can construct an equation. So in this case, for x, where x here is a Bernoulli random variable, this is the probability mass function shown in terms of a table, and here is the one in terms of equation. Okay, so if you want to look at example of graph, it could be something like this. Okay, so this is how you can construct the probability distribution using graph. You can see that this is the outcome, 0 and 1. Discrete case really, so we just have this straight line here. This one could be probability for failure, which is 1 minus p. This one is probability of success, which is at value of p. Okay, so if you want like specific example, specific value, you can see here this is valued at 0.2, and the probability of success is 0.8. You can see if you add them up, the probability here, it should be equal to 1. Okay, and another way of representing probability distribution using graph is you can use this form. Okay, so instead of having like one straight line like that, you may want to use a bar or something. So here we've got, you can see that this is the probability of failure valued at 0.25, and this one is probability of success, which is at 0.75. And again, if you add those probabilities, it should be equal to 1. Okay, right, so that's it. I think that's how you can relate what we are studying here with what you have already seen in the previous chapters. Okay, now let's try and do some simple proving. For example, how can we prove that the mean is equal to p and the variance is p1 minus p? And again, we're going to use the same idea, which is the idea of expected value, which you have seen in chapter 4. Okay, and let's start off by perhaps constructing a table, because that's quite easy to do. So here, when you have a Bernoulli random variable as what I have already shown here, this is an example of table that can be constructed to represent the probability mass function. Yeah, so let's start off with that. I'm just going to write down again the table. So we have 0 and 1, and that's the probability of getting 0 is 1 minus p. Probability of getting success, which is represented by 1 right here, is going to be equal to p. Right, now we're going to find the mean of x. Okay, so we're going to find the mean of x now. We have ex. Ex is going to be, according to what you have seen many times already, is going to be multiplying x with fx in the case of discrete random variable. Yeah, And we can see we have these two values of x, very easy to consider. So we're going to multiply this one 0 with 1 minus p and 1 with p, so 1 with p. So the answer that we get is going to be equal to p. So there you go, it is quite easily done. Yeah. Next, we're going to focus on finding the variance. Variance of x, according to what you have seen before, is just finding the expected value of x squared minus ex, and you square it. And I like to do things part by part, so we're just going to focus on finding this one right here first. Okay, so ex squared is going to be summation of x squared times with fx. Okay, so what it means is we're going to consider squaring each value of x. So this value here will be squared and will be multiplied with its probability, and then you're going to add up this one here will be squared and multiply with the probability as well. So what we have is 0 squared 1 minus p plus 1 square it with p. So we got the result here is going to be equal to p. Next, we're going to find what is variance of x. So variance of x is taking this value here, p, minus this value, is already obtained right here, and you got to square it. So p minus p squared, and you can factor p out. So factor p out, it will become 1 minus p, and this is what is shown right here on the right hand side of this equation. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video.